Students, in this video, we will solve some questions related to normal form of straight line. Solution number 1. Normal form is x cos alpha plus y sin alpha is equal to p. In first question, we have direct values of p as 8 units and alpha as 2 to 5 degrees. So substitute these values of p and alpha in this equation. We get x cos 2 to 5 plus y sin 225 equals to 8. X cos 225 may be written as cos 180 plus 45 plus similarly here y sin 180 plus 45 is equal to 8. X cos 180 plus theta be minus cos theta, so minus cos 45, theta is here 45. Similarly y sin y 180 plus sin y 180 plus theta be minus sin theta minus y sin 45, minus plus becomes minus equals to 8. Minus x cos 45 be 1 upon root 2 minus y sin 45 be 1 upon root 2 equals to 8. This implies x plus y equals to minus 8 root 2 or x plus y plus 8 root 2 is equal to 0 is the solution of this line. Second solution. In second question, find the equation of a straight line at a distance of 3 units from the origin. So this is the value of p such that the perpendicular from the origin to the line makes an angle of tan inverse 5 upon 12. If this is coordinate system and line is this, x-axis, y-axis, origin, and this is perpendicular from origin to straight line, and this perpendicular makes an angle, say alpha. So alpha is here given as tan inverse 5 upon 12. So alpha is tan inverse 5 upon 12, and this provides tan alpha 5 upon 12. So form a right angle triangle and say this angle alpha, this is right angle 90 degree, tan alpha be perpendicular upon base, so 5 upon 12, and by Pythagoras theorem we can find this side as 13, A, B, C. So by Pythagoras theorem we have AC square is equal to AB square plus BC square. Substitute values of AB and BC as 5 and 12. 25 plus 144, 169, square root is 13. So AC is 13, and this implies sin alpha in this equation, in this right angle triangle, perpendicular upon hypotenuse, so 5 upon 13, cos alpha base upon hypotenuse, so 12 upon 13, and now substituting values of sin alpha, cos alpha, and p is given as 3 units. 3 units. Substitute these values in x cos alpha plus y sin alpha equals to p. X cos alpha is 12 upon 13 plus y sin alpha 5 upon 13 and p is 3. This implies 12x plus 5y equals to 39. 13 3 is 39. So this is solution of this question number 2. And now question number 3. Solution of question number 3. Question number 3 is find the value of theta and p. If the equation x cos theta plus y sin theta equals to p is the normal form of the line root 3x plus y plus 2 equals to 0. x cos theta plus y sin theta is equal to P, and root 3 x plus y is equal to -2. Transfer this 2 to right hand side, sign will become negative. So these two equations are representing same straight line, so they are identical, and therefore comparing the coefficients means coefficient of x is here cos theta, and coefficient of x is in second equation is root 3. Similarly, coefficient of y is sin theta, and coefficient of y is here 1. This constant term is p, and here is -2. So solving first and third, this implies cos theta equals to minus root 3 upon 2p. Solving second and third, this implies sin theta equals to minus p upon 2. Equation 1 and 2. Squaring and adding these two equations. Squaring and adding equation 1 and 2, this implies cos square theta plus sin square theta equals to 3 upon 4p square plus p square upon 4. Cos square theta plus sin square theta we know 1, and this is 4p square upon 4, 4 and 4 cancel, p square, so p equals to 1. Not plus minus 1, because p represents the distance and distance always be positive, so we take positive sign, p equals to 1. And this is value of p, and substituting this value of p in equation 1 and 2. So from equation 1 we get cos theta equals to minus root 3 upon 2, and from equation 2 sin theta equals to minus 1 upon 2. Cos and sin both are negative, and both be negative in third quadrant, so angle is cos 210, and this is sin 210. If this is line, suppose this angle is 30 degree, then this whole angle from this to this point is 210, and 210 degree means cos 210 minus root 3 upon 2, and sin 210 minus 1 by 2. So theta is 210 degree. This is required angle theta, and required value of p is 1. These are the solutions of question number 1, 2 and 3. Thank you.